Friday's problem says, determine the trig equation that made the graph below. You can choose whether to view it as a sine or a cosine graph. That's up to you. The hint is that this is from chapter 4. So the picture that they have given us is over here. And one of the things that they did was they labeled only two of the markings, only two of the spots on the x-axis. This spot they told us was pi, and this spot they told us was 2 pi. When you look at the subdivisions of this, you realize that that's 1, 2, 3, 4, 5 markings to get to where pi is. So this is 5 equal parts that make pi. In other words, this is 1/5 pi, 2/5 pi, 3/5 pi, and 4/5 pi. So you might want to put those markings along your x-axis to fill in all of these spots so that you have an understanding of how best to solve this problem. One of the first things that you're going to want to do here is decide what kind of graph you're hoping to see. You may decide to see a cosine. You may decide to see sine. Maybe you're looking for upside down cosine or upside down sine. Whatever you're looking for, you could find it within here, but you have to pick one. So I decided to pick cosine. Now, you don't have to have picked this. I'll talk about what to do if you pick something different, but let's just start with this as an example. We know that cosine starts from the top. And to finish one complete cycle, you always have to end where you began. So if you're starting from the top, because I'm looking for cosine, that means I have to finish at the top as well. So the second step is to find the start and end of one complete cycle. Now that I've labeled all these markings along my x-axis, I know that I'm starting at 1/5 pi, and I'm ending my first cycle at 3/5 pi. So my start is at pi over 5, and my end is at 3 pi over 5. Where you start from represents the amount of horizontal shift that there is going to be in your problem. So because I'm not starting from 0, I'm starting from pi over 5. That means my graph had got moved over to the right pi over 5. I'll show you where that goes in the formula later. The next thing that you're going to have to do is determine the period from the graph, which is basically calculated by taking your ending value and subtracting your starting value. So my graph ended its first cycle at 3/5 pi and started its first cycle at 1/5 pi. Taking the difference between those is 2/5 pi. That's what you call the period. Now, the period does not show up in the formula by itself. So what you have to do now is use the period to help you figure out the frequency. The formula for period is 2 pi over the frequency. So if the period was 2 pi over 5, and that's supposed to be equal to 2 pi over the frequency, that means the frequency must have been 5. So frequency in this problem was 5. The fifth step is you want to find the midline of your graph in order to determine what kind of vertical shifting has happened. So I actually drew that in. This was not already in your graph. I actually put that in myself. And so you want to make sure that your highest and lowest values are equally spaced along your midline. So the highest I went was -1, the lowest I went was -7. So right in the middle of that would be -4. This should normally be the x-axis, and this means the graph has been moved down 4. So down 4 was our vertical shift. The last thing that you want to do is you want to determine the maximum distance that your graph goes away from the midline. This is what we call amplitude. So going from -4 to -1, or going from -4 to -7, in either direction, you can see that we're going 3 units away. So that means our amplitude is 3. We now have all the information that we need to be able to put the entire equation together. So here is your final formula. Y equals, don't forget to make it an equation. Then we need amplitude, which we figured out was 3. We had picked cosine for this problem. Next comes frequency. Then you're going to need a set of parentheses, because the frequency is supposed to be factored out. Next goes the horizontal shift. We've shifted pi over 5 to the right. And last, after the parentheses are done, goes your vertical shifting. We had shifted down 4. So this is the formula that represents this graph. Now, if you had chosen to do a sine graph or an upside down cosine graph, many of these pieces would still be the same. Your amplitude would still be 3. Your frequency would still be 5. Your vertical shift would still be -4. The only thing that would change if you decide to look at this graph differently is your horizontal shifting. If you decided to call this an upside down cosine graph and start from right here, Your 3 would be negative out in front because you're upside down, and you would have no horizontal shift whatsoever. So you would just want to get rid of this negative pi over 5. If you wanted to call this a sine curve and start from right here, you'd have to figure out where right there is. It would be at pi over 10. So this would be sine, and this would be minus pi over 10. Or you could look at it like I did, like a regular cosine.